My name is Scott Hanselman, and I work for Microsoft, but I work in open source, which makes it a lot more fun. I actually work for the Azure team and do stuff in cloud, and I work on ASP.NET, and everything that I focus on is around angle brackets and curly braces. And I was thinking about this and wanted to share a couple of thoughts that I had around the cloud and the browser, and to see what you guys thought. This is a famous quote that we can't prove that this guy said, that there is at most a market for 5 computers. This is a guy from IBM. I couldn't find a picture of the guy, so I found a picture of a really old guy from a book. So I'm just going to say that that's the picture of the guy. And in his mind, computers were this large, filling up a room kind of a thing, and that there would be a market for, maybe 5 of these. And it turns out that that was absolutely true, except it's the cloud. There's the Amazon cloud and the Google cloud and the Rackspace cloud. There's about 5 computers out there. They just happen to be made up of thousands and thousands of other little computers. So when I think about the cloud, we think about this virtual machine. There's all the different components of an operating system that one has. And if you think about operating system theory and you remember back to college, all the different components of an operating system, things like threading and storage and security and eventing. Surprisingly, these are the things that we associate with languages more than operating systems. But a while back, when I was writing C, these were characteristics of an operating system, but now they can be thought of as characteristics of languages, which I think is a really interesting idea. We take these virtual machines and we throw them into a data center and then we call it a cloud. I don't know, cloud is fun to say, although data center is what it is. But the nice thing with these virtual machines is that you can move them back and forth, not just from your data center to the cloud, but to someone else's data center. And when that company gets big enough and they decide that their data center is officially a cloud, then we're moving from cloud to cloud. But the point is that we have portability. We're not locked down. We are literally moving machines around as fast as we can copy those machines, which is a really comforting feeling. And being able to scale up means to add more of these machines. And it wasn't too long ago when I would build a new machine in our farm, and I would run down to the local computer store, and I would buy another physical machine. It would take an entire day to install the operating system and to go and set up an all-new machine. It was a pretty extraordinary time. And then fast forward today, and you can run Linux in Azure, which is insane, right? Because we're evil. It doesn't matter that it's the Azure cloud. It can be anyone's cloud. You can do this on Amazon and other cloud providers. But the fact that we can do this is amazing. It's mind-blowing. We couldn't do this a little while back, and now we can. And when I hear about people not moving to the cloud, how can you not want to go to the cloud when you can do this? Put that in a for loop, and that's file new company. That's truly, truly amazing stuff. Being able to create websites and scale them up with a simple slider bar is such a joy. To say I want 2 and no, I want 3. And the best part about the cloud is that it doesn't care about your language choice. You can do this stuff in any language that you want. You can run Node. You can run Java, PHP. And the best part is that it's open. This is so important. A good cloud is an open cloud. You need to be able to see what's going on inside. You need to not feel like it's abstracting away something that's not to be abstracted away. A good cloud abstracts away complexity, but is still open. We're doing all of our stuff as open source. So actually right now, all of the Windows Azure stuff is open source. If you haven't heard, it's just important to point out that it's a kinder, gentler Death Star over at Microsoft right now. Everything's up on GitHub. So now I've gone and made a new website from scratch, created it, provisioned it, and now it's running in the cloud. That's what a cloud should do. We need to expect that from the cloud. It used the open source tools that I want. It'll use any language that I want. It uses Git if I want. Choice, 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 everybody. That's what it's about. You may have heard also that ASP.NET, MVC, Razor, Web API, it's all open source now. And this is another important point that's great about the web right now, is that this isn't source opened. This is open source. It's really easy to zip up source and put it online and then put a really unfortunate license on it that says, look but don't touch. I think it's great that Martin Fowler's taking pictures of me right now. Action pose. Get an action pose, Martin. No. It's going to be pictures of me looking like a pundit. It's all open source. Now, even if you want to use IronPython, that's cool too. I don't care, but maybe you're not. Maybe you're into Python. Maybe you're not. It's all good. We support whatever you want in the cloud. Now, this is something I wanted to show you that we've been thinking about. This is so early that it doesn't even have a name yet. We're just putting quotes in it. And I wanted to show you to get your ideas about what else one could do with the cloud. Because we saw that we can make virtual machines in the cloud. That's great. I can make websites where I'm even abstracting away the virtual machine underneath, and I can dial that up and dial that down, and I don't even know where that website is running or on what virtual machines. But oftentimes we find ourselves doing work with batch systems. And these batch systems typically end up doing something in a console app, and then you want to take something like this where I'm going to modify some text file, and I want that to scale up. Maybe I'm going to take a couple of images and I'm going to resize them. Or I'm going to take some PDFs and I'm going to OCR them. The New York Times recently did this on the Amazon cloud, where they took 100 years of scanned New York Times issues and then turned them into PDFs, all using the cloud. These things start out in little console apps. So here's an example of a silly little console app that reads in some text, and then on the output, it writes a line of content and then a little bit of information that it in fact happened in the cloud. So we've abstracted away this kind of batch process idea so that locally it's as simple as running a console app, and in the cloud it's as simple as just copying the executable up there. It's scanned, that function is found, and now I can invoke those functions. And if I want to run them on one text file or 5 terabytes of text files, the cloud will scale up for me. So now those virtual machines live on the server, but there's another virtual machine that we're forgetting about. And when we design systems, we design them in such a way that we keep wanting to scale up the server. I keep seeing people ship huge amounts of data back and forth between browser and server as if the browser was stupid, as if the browser was incapable of doing any actual work. I think that it can do a little bit more work than we give it credits for. And I've been thinking about this. So remember our view of what an operating system is. Operating systems handle memory management. Operating systems have often a graphics subsystem of some kind. They have networking and eventing and things like that. Well, once upon a time, you would have a machine that looked like this, that was kind of powerful for the time, but really not very powerful, and it always needed a friend in a back room somewhere to do the real work. And in a system like that, if you wanted to go and Google something, you would visit a terminal like this. And you would go and Google it with your terminal, but the screen was actually rendered as a ASCII or ANSI or VT100 and sent across the wire and then displayed here. So you felt powerful, but you were really seeing a view into someone else's power. So then someone created the web page. Not a web page, but the web page. This is the one web page. This was the first one. And it's living inside of this terminal, this dumb terminal that we call a browser. It's living in user mode, and it's a view on some text format. Instead of VT100, it's HTML. Then this happened. And this is super interesting, because here someone is deciding that the operating system needs a little help, so we're going to make another operating system, and we're going to run it inside of this user mode browser. And that seemed like a really cool idea. And then these guys said, yeah, we totally going to do that too. And then these guys were like, hey, remember us? We control YouTube. And we have all these other virtual machines out there with all these operating systems that are running inside of our browser. So now we've got an operating system inside of a plug-in virtual machine inside of a browser. But that operating system is legit. It's a legitimate operating system. It's got memory management. It's got its own kind of threading. It's got events. Forget Windows, forget Mac, forget Linux. You can go and write to this operating system. And that'll be a great idea, won't it? That'll be an awesome idea. And then we'll go and we'll have the terminal thing be in there. Which is bizarre. I was recently at Toyota and I had the oil changed on my car. And the guy said he needed to log into the back-end system that managed the appointments for Toyota. So he launched Windows, logged into Windows, launched Firefox, went to a page, launched Java, which then loaded a jar file which contained a VT100 emulator, which then talked to a back-end mainframe. And he says, and it's so much better than it used to be. Somebody thought that was a really great idea. And no one noticed while it was happening. Do you guys know how to boil a frog? You know how you boil a frog? You turn the heat up slow, and the frog doesn't know that he's being boiled. By the time the heat gets too hot, well, frog's dead. But imagine if you hadn't been on the web for all this time. Imagine if you didn't grow up through this process. Maybe some of the younger people haven't. Then you're being thrown into a hot pot as a frog, and you're going to be like, I'm not going to be boiled today, and you're going to jump right out of that hot pot. So you're going to come up with a different solution, and I think that that's what's happening. The funny thing about the Java stuff was that you'd have this HTML that represented some document, because remember the Tim Berners-Lee original view was this hyperlinked series of documents. And then you'd have an island of activity, like a little window on another world that was this virtual machine. And you would know that it was Java because there was always physics demos. And the entire internet consisted of web pages and teapots. And you knew that a teapot was coming because you'd navigate to the next page and then, oh no, Java's coming! And then it would load, and that was really awesome. And then you'd have a physics demo in your browser. And JavaScript was a toy, right? JavaScript was this silly toy that people would use to bring up alert boxes, or if you were really fancy, do text validation. And that was an amazing use of JavaScript. And someone would say, wow, I wish that I could do JavaScript like that. And they would make things that people couldn't believe. Pac-Man, entirely in JavaScript. That's amazing, oh my God, I can't believe they just made Pac-Man in JavaScript. And then like, wow, I guess JavaScript isn't only a toy. But that wasn't enough for some people. Some people had to really break the rules. And they would implement entire other operating systems in JavaScript. Oops. Because what good is it to have that many layers if you can't play Galaga, right? This, in my mind, was when that bit switched in my brain and I realized that you could really do some damage with JavaScript. They had a virtual machine. Now, mind you, a 25-year-old virtual machine with 64K of RAM, but still a complete virtual machine implemented on top of something that we did not think was a virtual machine. JavaScript's a toy. How did they get from alert and text box validation to this? And then this happened, and my mind was blown. This is a complete implementation of a x86 virtual machine, including Pentium processor flaws, because at Intel, quality is job 0.9999. And it's done entirely in JavaScript. And how do you know if it's JavaScript? We all know the trick. You try to select it. Oh my God, I could select the text, it must be real. Because someone would show you something and then you'd right-click and it would say Flash, and you'd go, come on, that's cheating. You're using a real virtual machine. JavaScript's just a toy virtual machine. Well, what if I could take this toy virtual machine and then compile something in C? So now I'm inside a browser running JavaScript, running Linux, faking an x86 in user mode, and now I'm going to compile a C application and then say hello world. That's disturbing. But that wouldn't be the most disturbing thing that I could show you today. This would be far more disturbing. Shall we? Let's fire up Linux inside of a browser, inside of an iPhone simulator on Windows. So if you haven't realized that JavaScript is the biggest thing since God talked to Moses, too much? It's a big deal. Then you have no soul. And I say that with all due respect. So JavaScript is no longer a toy. JavaScript is itself a complete operating system. I mean, drink that in for a second. We're all fighting about Macs and PCs and Linux, and we've got this operating system from the people that has snuck in from the side, asking nothing of us, just to love it. And it has all these things. You've got web workers for threading. You've got events. You've got a half dozen different networking options. You've got passable garbage collection. You've got 3D and 2D. This is amazing. And it's on the pocket supercomputer that happens to ship in my phone. This can actually be changed, and you can just say Excel. And that will also be true. That is as true as it ever will be, and every day it becomes more true. You've got a complete operating system that ships with your tiny mobile phone, and it lives inside the browser. And that's why we should really be concerned that the mobile people who want us writing native apps are maybe not going to let that move forward as much as it needs to. Now, Zuckerberg said this. He said that HTML5 was a mistake for him. It was a bet. I respectfully disagree. I like this quote instead. The avalanche has begun. It is too late for the pebbles to vote. What wise person said that? Anyone? No? Any guesses? Babylon 5. It was actually Kosh from Babylon 5, but nicely done. Thank you. No prize for you, though, but good effort. Good effort. Thank you for going out on a limb there. Yeah, I thought it was the other guy, too, but no, it was Kosh. Some of our greatest wisdom, and one of our finest philosophers. Whether or not Zuckerberg thinks that it was a mistake doesn't matter. It's happening, and he doesn't get to vote. And that's really powerful. So it's up to us, the users, the developers, and it's up to the vendors to make it more enjoyable. Because it is going to happen. It has happened. So get on board while you still can. HTML5 and CSS3 are becoming really interesting. Now, HTML, though, that was really hard back in the day. Do we all remember the first time we learned HTML? What was the hardest thing that you could do in HTML? What was the pinnacle of technical achievement in HTML? Were tables. Because if you could make a table and master the row span, well, you could have a job like that. You know tables? I do know tables. Row span and call span? Please. I can nest tables up to the actual theoretical maximum of nested tables. I actually know I was there when I hit that maximum in Mozilla, that there was a maximum number of nested tables, and I'm proud of that. In this time, HTML was getting bigger and bigger and bigger, and the markup was getting more and more and more complex. And then suddenly, it disappeared. Suddenly, the markup didn't matter. You could make amazing things with a single element. So then, maybe it's not all about HTML5. Okay, what that would have been is a single element div class iPhone, and 100 lines of CSS, pure CSS, no PNGs, no fancy graphics hacks, and the guy draws a complete and perfectly pixel-perfect accurate iPhone with CSS. No JavaScript, one element. The element doesn't even really need to be there. The element could be implied, I suppose, but he needed something to hang it on. The fact that people are doing stuff like that is really significant. It should give us pause when we think about what's really doing the work if HTML isn't involved anymore. If HTML is only the structure, then CSS is the look and the color and the style. But if you were going to take that iPhone and make it do something and give it life, it would have come down to JavaScript, because that's doing everything else. Now, there's lots of implications around this for accessibility. There's lots of implications around Googleability and what it means to have an application that is primarily in JavaScript. But ultimately, knowing JavaScript is what you're going to have to do to get a job. Yeah, he did not nail it, in case anyone is confused at all. So we've got virtual machines, we've got complete implementations of other operating systems, we've got the ability to create full applications and bring them down with JavaScript. It's clearly the assembly language of the web. Who said that? Me. I said that. And everyone else said that also, because it's totally true. And anyone who doesn't think that it's true is just wrong. I wrote a blog post about this where I declared that that was the truth. And then immediately, a bunch of people declared that that was nonsense, that was insane. Well, maybe it's not the assembly language of the web. Maybe it's the Lisp of the web. Or maybe they're just making up all sorts of other stupid analogies to go against my analogy. So I called some people that know JavaScript, like the guy who invented it. And he said, that's actually Brendan Fraser, the actor, there on the left. But that's Brendan Ike. But he's prettier. So Brendan Fraser said that he said also that JavaScript is the x86 of the web, which is pretty much close to saying it's the assembly language of the web. But he can't claim that it's original. This is what's great about thoughts like this, is that they are all original thoughts, because we all had them at one time or another. It's just whoever tweets it first gets to claim it's their idea. But when he said that, and then when Douglas Crockford agreed, it's like, okay, this is pretty clear. That's happening. So what do you do when you have this assembly language that you can start targeting? Well, you start building languages on top of it, because what better thing to do than to write a layer of abstraction on it? So CoffeeScript is this kind of lovely layer that targets JavaScript. And our very own Anders will present on Wednesday about TypeScript, which is another layer on top of JavaScript to make it friendlier, to make it the language that we wish it could be. Because remember that JavaScript happened in a fairly organic way, and I don't think anyone necessarily likes all aspects of it. So there's a little bit of tidying up that's happening. It's unclear whether that will happen with languages like TypeScript and CoffeeScript, or whether that will be fixed in the next version of JavaScript or not. But the point is, it's on everyone's machine, and it is a free virtual machine we need to start utilizing. But I would encourage people to not let layers hide too much complexity. You've got this JavaScript operating system and this virtual machine, and people are continuing to build layers on top of layers. There's another fun quote. No one writes JavaScript anymore. They write jQuery. I don't like meeting programmers that tell me that they're awesome JavaScript programmers, and then you realize that without jQuery, they would not be able to program. Now, that's different than being unable to program without Google, which is something that I can admit to. I am completely incapable of programming without Google. But you need to be able to write JavaScript at the root. This was the case 20 or 30 years ago when I first learned C. Before I learned C, I had to take an assembler class, because the C guys were like, C is going to let you do really powerful things, son, and I need you to understand what those powerful things are really doing under the hood. So let's learn x86 first. Now people don't do that. Now they say, Java and C#, son, are going to allow you to do some really powerful things. So you're going to need to learn C first. And they're slow, and pretty soon it's going to be like foo-foo script from Anders Heilsberg Jr. is going to allow you to do really powerful things. But we're going to look at C# first before we learn that. Who said that? Well, I also said that, because everyone says that. You really want to build these amazing things. You get this image in your mind about all this cool stuff that you're going to snap together with these components. And if you snap them together without thinking about your components, they're going to end up looking different from what you expect. And you're not sure who you're going to be able to blame. And then you're going to feel sad. So I would encourage people to try one JavaScript library. One JavaScript library, vanilla.js. Now this is a little bit of a tease, but it needs to make us remember what we're standing on top of. Whose shoulders are we standing on top of? And when we go and create our new startup, and before we make our startup, we say, all right, we're going to make the world's greatest to-do list. It's going to be awesome. But before we write to-do list, we need to write a new DOM traversal library. It's going to be way better than everything before it. We need to ask ourselves, are we really rewriting, malloc? Is our malloc going to be better than the one that's built in? So I think we need to expect more of our web tools, and I think there's still a lot of innovation to be had there. To remember that we've got these virtual machines. And when you're designing a system, don't forget that you have that virtual machine available on the client, and you can make that do some really interesting stuff. On the cloud, you've got this great scale, this elasticity, you've got your choice of languages. But on the browser, you've got accelerated graphics. Even a crappy Android phone has a dual processor, and the slightly less crappy ones have 4. Get them working. You've got this integrated VM that's running. On the cloud, you can have unlimited virtual machines, and you can use whatever language makes you happy. In the browser, you can either write JavaScript or target JavaScript. And if you remember that the user's virtual machine is part of the cloud as well, what could you do to put that to work? So I would encourage you to be thinking about this. It's happening really fast, and I recognize that the internet is moving forward quicker than we can get our brains around, but you're not obsolete. You have the computer science concepts. You think about this kind of stuff. I hope I've given you a slightly different way to think about things so that you will feel that you are powerful and might design your systems in a slightly different way. And remember that there's a new operating system that's shipping every single day, and you just have to press F5 to reboot it. So get to work. Thank you very much.